going to talk about finding derivatives of exponential and logarithmic functions, particularly functions that require the use of the chain rule, product rule, and quotient rule when you're trying to find the derivative of them. So this first function here is a composite function. Okay, it has the exponential function with a polynomial function within it. Okay, so to do this, I need to take the derivative of the outside piece and then multiply it by the derivative of the inside piece. So f prime of x, the derivative of the outside will be 3e to the 3x minus 5, and the inside, since it's 3x minus 5, the derivative of that is just 3. Okay, so f prime of x is equal to 9e 3x minus 5. Okay? So let's try the next one. This one is also a composite function. It has a polynomial within a natural log. So to find this, we need to first take the derivative of the natural log. Well, the derivative of the natural log is just 1 over what's ever inside the natural log. So 1 over x cubed plus 3x. And then I want to multiply that by the derivative of the stuff inside the natural log, so it'll be 3x squared plus 3. Okay, so let's simplify this to 3x squared plus 3 over x cubed plus 3x. Now this is as simplified as it will get. If you try factoring it, you'll see that there are no common factors in the numerator and the denominator, so nothing will cancel out. Okay. Okay, so to find the derivative of this function, because it is two separate functions being multiplied by each other, we're going to need to use the product rule. Okay, so the derivative of f of x is equal to first times the derivative of the second. Well, that's going to need to use the chain rule. Okay, so e to the negative x, and then the derivative of negative x is negative 1, plus the second times the derivative of the first. Well, the first in this case is 2x. Well, the derivative of the first in this case would be 2x. So let's clean this up. So this is negative x squared e to the negative x plus 2x e to the negative x. Okay. And if you don't like negative exponents, which I personally don't, then you'd write this as negative x squared over e to the x plus 2x over e to the x. But now we have two fractions with the same denominator, so we can combine those to make it negative x squared plus 2x over e to the x. Okay, so to find the derivative of this function, we're going to have to use the quotient rule because we have two functions being divided by each other here. Okay. Now, to find the derivative, we need to do bottom times derivative of the top. Well, the derivative of the natural log of x is 1 over x, minus the top, so the natural log of x, times the derivative of the bottom, which in this case is just going to be 1, over the bottom squared. Okay, so if we clean this up, x times 1 over x is just 1, and the natural log of x times 1 is just the natural log of x over x squared.